I'd like to share with you an interesting trick that a DHCP server can do, and that is to dynamically update a DNS record on behalf of a client that just got an IP address. Let's begin. I'd like you to imagine it's a Tuesday afternoon and we're walking back into the office and somebody says, the network is down. And so we ask some questions and it turns out a user cannot ping a system based on its name. They type in ping space, the name of that system, and it doesn't work. Well, there's lots of reasons why a ping may not work. We may have firewalls in place. We may have access control lists that are allowing the ping to go through the network. Or it is possible also that name resolution isn't working. So after some investigation, we discover that the problem is that this device, client2-nug.nuggetlab.com, cannot be pinged by name. And because it has a dynamic IP address, that IP address could change from time to time. And we step back from the picture and we say, well, when we configured in our previous nuggets, when we configured DNS, when we set up the zones for nuggetlab.com, we allowed dynamic updates if they were secure, which implies that if computers are members of the domain, they can go ahead and update their DNS information once they get a new IP address via DHCP. And that, unfortunately, is what's causing our problem right here with Client 2. Client 2 is not a member of the domain. And as a result, when it gets an IP address like 10.0.0.125 dynamically from the DHCP server via the DHCP relay, even though it knows who the DNS server is, based on the option for DNS server that it got. And at the moment, our DNS server is only allowing secure dynamic updates. So it won't allow a client like Client 2 to update a record. Now, we have a few options to address this. One option is we could go to the DNS server configuration and say, please allow secure and non-secure updates, which is a less secure idea. Or, which is the purpose of our nugget today, we could go ahead and have the DHCP server talk to the DNS server and have the DHCP server itself do a DNS update regarding a record and a pointer record, if we want to include that as well for reverse lookups, regarding a client. And if we configure that in DHCP, when the client gets an IP address from the DHCP server contacts the DNS server, and if they're running on the same machine, it's a little internal conversation, to do the dynamic update of the record. So it's an alternative approach to having updated records in DNS, and the alternative is having the DHCP server do the update on behalf of the client. Now, on the DHCP server, in the properties of IPv4, we can control that behavior. And what I'd like to do is walk you through the configuration of that in both the GUI and through PowerShell. And then I'm going to encourage you to practice this hands-on. And you can get that hands-on practice, of course, in the hands-on labs that we provide for you. So I've powered on both the Client NUG and Client 2 NUG. And we're sitting here at Client NUG, and let's go ahead and launch Server Manager using the icon in the taskbar. On the dashboard in Server Manager, on the left-hand side, let's go ahead and click on DHCP. And it lists our single DC-NUG server, which is acting as a DHCP server. So let's right-click on DC-NUG, and from the drop-down, select DHCP Manager. And let's go ahead and expand that full screen. And I'll rearrange it a little bit to make it a little bit easier to read. So currently, before we start making any kind of changes, let's expand IPv4, and we have two scopes. If we expand those two scopes, one for the 10 network and one for the 192.168.1 network, and if we click on address leases for each of them, for the 10 network, we've got one at 10.0.0.125. That's Client 2. Fantastic. And in the scope of 192.168.1, under address leases, we have our reservation of 192.168.1.150. And that's because both those machines are powered on. But what's interesting is that those two IP addresses, .150 for Client 1 and .125 for Client 2, those are not both in DNS. Client 1 is because he's a member of Active Directory and dynamic updates to DNS are allowed. Client 2 is not because Client 2 is not a member of the domain. So to verify that, we have several tools at our disposal. We could launch DNS Manager and look at the A records there, or we could use PowerShell related commands or NSLOOKUP to verify that as well. So for our lab, let's go ahead and click on the PowerShell scripting environment. There's an icon in the taskbar for that. And for this lab, I've got some commands pre-baked for us. If you want to bring them up, you can click on the folder icon or do a file open. And in the temp folder, there's a file called 34-DHCP with updates to DNS. Let's go ahead and open that. And before we train our DHCP server to do updates on behalf of the clients who get IP addresses, because we can dynamically update host records in the forward zones like A records and reverse lookup zones, referring to pointer records, I want to also just create a reverse lookup zone for our 10.0.0 network. so that when we tell it to create a pointer record, there's actually a reverse lookup zone to put it in. So to do that, I want to use row number 5, add dash DNS server primary zone, and then instead of opening up a remote shell to DC-nug, I'm just going to call out that computer with dash computer, DC-nug, and then create a reverse lookup zone for network ID 10.0.0, and that'll be kept as part of Active Directory. And that's a little flashback to our DNS nuggets. So with row 5 highlighted, we'll go ahead and press F8 to execute that. Excellent. So now we have our reverse lookup zone. And also, before we make any changes, if we want to do a query and take a look at the records in one of our zones, we could use one of many get commands, including get-DNS server resource record off of the computer DC-nug, looking specifically at the zone name of nuggetlab.com and looking specifically for A records. And with row 8 highlighted, we'll press F8 to do that. So in our output, we have a entry for client-nug at 192.168.1.150, but you'll notice we don't have one for client 2. If we wanted to query the reverse lookup zone that we just created, it's going to be mostly empty. It's not going to have any pointer records in it. It'll have a start of authority record and a name server record, but no pointer records because there haven't been any created. So row 9 is simply looking for pointer records in that reverse lookup zone. So with row 9 highlighted, we'll press F8 to execute that, and it comes back empty. There are no pointer records yet in that reverse lookup zone for 10.0.0. So let me share with you how we would configure the dynamic update of DNS from DHCP using the DHCP manager. So there's an icon on the taskbar for that that's open at the moment. We'll click on that to resume our DHCP manager. And to configure the dynamic updates of DNS from the DHCP service, we simply click on IPv4, and then we'd right click on IPv4, and from the drop down, select the properties of IPv4. And then the second tab over is DNS. And these are the default settings, which are to dynamically allow DNS record updates if requested by clients. And because the DNS server is only allowing secure updates, that would also limit the scope to secure updates from clients that want to do it. And if we wanted to change that, if we want to say always dynamically update DNS records, we'd click that radio button right there, and then it wouldn't matter whether or not the client requested an update to DNS. The DHCP server would just go ahead and do it. By default, when the lease is over, when the lease is deleted, it's going to discard the A and pointer records that it previously created. And there's also an option for dynamically update DNS records for DHCP clients that do not request updates. For example, a really old device that has no idea about requesting an update to DNS, a check in that checkbox would allow that as well. And if we don't, for whatever reason, want a reverse lookup created as a pointer record for those dynamic updates, we could put a check in the checkbox here saying disable dynamic updates for the pointer records. And then it also gives us an option here for name protection. If we click on configure, right here, this button for name protection, it's not enabled by default. And here's how name protection works. If the DHCP server is about to do an update to the DNS, but there's a different client that's already registered the same name, the update won't take place. And that's why it's called name protection. It's not going to allow the overwriting of that information if it's already present in DNS. So I'm going to click on cancel there. I'm not going to change any of these defaults. And I'd like to show you how you can set these values if you'd like to with PowerShell. So let me click on cancel here, and let's go back to our integrated scripting environment. In our scripting environment, I've got a command at line 12 for set-DHCP server v4 DNS setting. And then dash computer is saying we're going to apply this to DC-nug. The dynamic update always means it's going to do it whether the client requested it or not. And update for older clients being set to true is going to do it for clients that don't have the capability of even asking for the DNS update. And if we scroll a little bit further to the right, I've also set the option for deleting the DNS resource record based on the lease expiring and setting that to true. So if we highlight row number 12 and we hit F8 to go ahead and run that, that applies those configuration changes to the properties of our IPv4 in DHCP. Now, if we go back and look at the graphical user interface, we'll go ahead and click on the DHCP manager icon in the taskbar for that, and then go back to IPv4, right click, and go to properties of IPv4. And then click on the DNS server tab once again. You'll notice that the changes we made in PowerShell are reflected here, so including the fact that we want to always dynamically update DNS records, which will help us solve our problem with Client 2 because Client 2 can't do that dynamic update on its own. So having done that, let's go ahead and minimize the DHCP manager. And using the hands-on lab environment, let's go jump on the console of Client 2. So here we are looking at the desktop of Client 2. And we have several options in renewing the lease. We could disable and re-enable the interface, or we could do an ipconfig/renew. And that's probably the most direct way of doing it. So to do the ipconfig/renew, let's right click on the Windows icon in the bottom left-hand corner. And from the menu, let's select command prompt. And let's do an ipconfig. Actually, I'm going to do an ipconfig and press enter first, just to verify we have an IP address to begin with. Great. We could also do an ipconfig/all if you want to see all the detail. And I'm going to hit the up arrow key again, a space, /renew, and press enter. So while that goes on, as a brief reminder, we've configured server 2 as a router, also as a DHCP relay listening on Ethernet 1 for new clients. However, if a client has an IP address and it knows who the DHCP server is, if it's just like halfway through its lease and doing its normal renew, it'll just send a unicast message, a request, directly to the DHCP server, and the server will reply back with an acknowledgement saying, yep, go ahead and take it, here's your new lease. So the DHCP relay function on server 2 wouldn't be too critical for a unicast renewal of an IP address between a client and a DHCP server. However, server 2 does play an important role in routing between those two different networks. So now that I've given ourselves a few moments, let's go back to the command prompt. And it shows we do have an IP address, 10.0.0.125. Fantastic. And what we're hoping for now is that in DNS, we have a dynamically updated record for client 2. Now, we are sitting at client 2, but we can still use a command like nslookup to make a query to a DNS server to ask about the IP address for a certain host. In this case, we're asking about ourselves. So we'll go ahead and launch that, and that came back. Great. And if we did a reverse lookup, for example, asking regarding an IP address, that should also work if there's a pointer record as part of the reverse lookup zone for 10.0.0. So with nslookup looking for the IP address, we'll press enter. And that does come back as well. That's fantastic. So we can test it that way. And also if we go back to our client 1 machine, so let's do that. Back at client 1, if we go back to our integrated scripting environment, we could also run commands 8 and 9 again, which are looking for A records and pointer records in their respective zones. So let me squeegee off the bottom portion here and resize this just a little bit. And let's go ahead and execute row 8 by highlighting it and pressing F8. So there's client 2-nug at 10.0.0.125 as an A record. And row number 9, if we execute that by highlighting it and pressing F8, it came back and showed us all the pointer records in that zone, which is just the one for our host ending in .125, which is client 2-nug.nuggetlab.com. So now, as a result of our time together in this nugget, if we have a situation where we have a PC that's not part of the domain and cannot do a dynamic update of its IP address in DNS on its own, we know how to configure the DHCP server to do that dynamic update on behalf of the client. And now, my friend, it is your turn. Have some fun in the labs. I would ask you to replicate and practice what we've done together in this nugget. And when you're done, I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.